Hello everyone, this is FMT 123 Fall 2020, and this is my final project, the water level sensor. As you can see here, we have the sensor. It has power indicated by the LED blinking hooked into the Arduino board. And how this is going to work is that as I lower it into this cup of water, it's going to give a reading. And as it reads, it's going to light up these LEDs and then print to the serial monitor. As you can see now, the water level is empty. As I lower it down, it'll go from low, medium to high. Red LED on for low, yellow for intermediate, green for high. How does the sensor work? Well, as you can see, it has these 10 copper traces here. 5 of them are sense, 5 of them are power. By themselves, they're completely worthless. As you lower it into the water, they gain conductivity and create a parallel circuit. Less water, higher resistance, different reading to the Arduino board because this is hooked into the analog in pin. As you lower it further into the water, it gains less resistance due to more conductivity and gives a different reading. And that's how the Arduino, coupled with the program, is able to understand what's going on here. Now I've chosen to lower the sensor into this cup of water, or half-cut water bottle if you will, because I don't have enough hands to operate everything as far as filling this cup up, and I don't really want to be splashing water around sensitive electronics. So let's go ahead and lower the sensor into the water and we'll see what it does. So you got the red LED, it's on low. Going further, we get the yellow LED for medium, and going further down we get the green LED for high. And that's pretty much it. The pins on this sensor are kind of similar to the servo motor, as in it has a, if it would focus, has a negative for ground, has a positive for the power, which could either be a 5.5 or, as a 5 volt DC or a 3.5 volt DC power input. And then there's the sense pin, which goes to the analog in. I have these LEDs set up in line with the 220 ohm resistors, and they're plugged into the according pins. Let's go ahead and take a look at the program real quick. And you'll see that we have the upper and lower threshold. That gives the actual reading. That's the part that had to be calibrated as the sensor reacts to the water. All water types are different. This is the standard tap water in my area. Pure water is not conductive. It is the actual minerals in the water that are conductive, so you have to adjust for that. I kind of played around with these settings until it gave me a proper reading. It seems at different temperatures it reads a little different as well. Pretty standard setup. Defining the pins, setting up the serial monitor, setting up the LEDs, allowing it to read, setting up the functions for all that. That's pretty much it. Take a look at the wiring diagram real quick. Fritzing didn't have much in the way of colored LEDs or an actual water level sensor, so I chose this humidity sensor. Pretty similar. And there's the rest of the diagram. And for the wires on this sensor, that's actual piece of cable ribbon that I tore off. Seemed to work just fine. Now, why did I choose this project? I chose this project because these sensors are very common throughout industry, throughout process controls. You can find them anywhere from the petrochemical to power generation industries, food plants, wastewater treatment. Any place that has a type of holding tank or a fluid process, there's going to be a sensor like this around. They're even in your water heaters in your home that help to modulate the water level within the said water heater. You know, so you get hot water when you're supposed to and it doesn't overflow and damage your home. Otherwise, they're all over the place. They give valuable data to the controls room, the control centers of plants of various types, you know, that process controls engineers can look at and analyze, as well as giving data for operators to go off of when they need to make their adjustments. Long gone are the days of staring at analog gauges and operating valves by hand. Everything's done automatically now with solenoid operated valves and different implements of that sort. So that's why I thought this was important, because your real PLCs that we would usually be working on if COVID hadn't taken us out of the classroom control sensors all throughout facilities like that and help to control the process of whatever you're trying to do, whatever kind of fluids or substrates you're trying to move around. That's why I felt it was important to get a grasp for this and how they work. There's various types of sensors in the industries. This is one type. They have a lot of float ball sensors, and a lot of places I've been in kind of have pickups on them, and as they float up and down, they lose or gain resistance. There's also sonar types that bounce waves off the surface of the fluid up to the top of the tank and back down again, and then the sensor would read the wavelengths and report the acquired data. And that's about it. I think it's a good thing to learn. I think sensors are very important, not just level sensors, but area sensors, proximity sensors. They're all pretty important in various industries. It's a good idea to get your head wrapped around that sort of thing. And that'll be all for this one.